Hello and welcome to pH Chemistry. Today's explainer is cracking, breaking big hydrocarbons into smaller, more useful ones. By the end of this video, you'll know why we do it, what comes out, and the two main methods. Cracking breaks down long-chain hydrocarbons into shorter, more useful ones by heat and often a catalyst. Each cracking step produces a smaller alkane plus at least one alkene. Why crack? Well, demand for petrol and diesel exceeds the supply from raw fractions, and alkenes are needed to make plastics. Three things. 1. Uses heat, sometimes with a catalyst. 2. Products, a smaller alkane and at least one alkene. 3. Catalytic cracking uses a hot catalyst. Steam cracking uses very high temperatures with steam, mainly to maximize alkenes. A common slip: forgetting to balance the equation. Cracking is a chemical change. Atom counts must match. If you have 10 carbons going in, 10 carbons must come out, split between the products. Quick example: C10H22 goes to C8H18 plus C2H4, i.e. octane, a petrol component, plus ethene, a polymer feedstock. One useful product plus one even more valuable one. That's why oil refineries crack heavy fractions extensively. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus mastery workbooks across maths, physics, biology and chemistry. One for every higher topic in each of the subjects, with every answer fully worked and every common slip flagged. Simple explanations, serious results. See you next video.